Hi, holy crap. I've recorded this video multiple times now because I keep either screwing up or not hitting record. I'm gonna try to make this fast. We're doing more factoring stuff. This one's factoring Quartics. Quartic means that it has a power of 4, so big power stuff, right? Big old polynomials. That one's the power of 3. Factoring Quartics. This is a hyper-specific trick that only works if you have something that looks kind of like this, right? Where it's missing some pieces. There's no x cubed in there. There's no regular x in there. It's just an x to the 4th and an x to the 2 and then a non-x number, right? So this trick only works on very specific questions, but it's not that crazy of a trick, so we're going to do it. So first of all, notice that this looks really similar to a quadratic, right? Like if we were to take these two powers and then just cut them in half, right? Divide the 4 by 2, divide by the 2 by 2. If we were to just cut those in half, then we would have x squared minus 3 regular x, right? Those would cancel out. Minus 54. Now it's just a regular old quadratic, isn't it? And that would be easy to factor. We just do an x puzzle, all right? So let's do that. Negative 3 on bottom, negative 54 on top. Two numbers multiplied, negative 54, combined to negative 3 are negative 9 and 6. So that means our factors would be x minus 9 and x plus 6. But remember, for all these little tricks, anytime you do something weird in the beginning, like how I cut all the powers in half, cut the powers of the x's in half, well, now I need to undo that. If I cut them in half, well, now I need to double them, right? So right now they don't have powers, so I need to double the power, which means they got a power of 2 now. And there we go. Mostly. We're not done yet. That's the big trick, though. So basically, you can cut the powers in half, turn them into, to turn it into just regular quadratic. You treat it like a regular quadratic, and then you can just double up your x's at the end, and then there you go. This isn't quite done yet, though. So let's look at the factor on the left there. That one right there is x squared minus 9. Usually when you're doing factoring, you want all of your factors to just be x plus or minus something, x plus or minus something, not x squared plus or minus something, not x cubed plus or minus something, just regular x plus or minus something. So the fact that there's still 2 on there is kind of a problem, not a big problem, but it's kind of a problem. If you can factor them further, then you should do it. If it's like you could factor it, but it's like a gross irrational number, then it doesn't matter. You just leave it alone. But so let's look at this one right here. X squared minus 9 is a difference of squares problem, right? X squared minus difference minus 9 is a perfect square. You can take the square root of 9. It's 3, right? So I'm not going to talk a whole lot about how the difference of squares works because that's old news from last semester. If you don't know how I'm getting what I'm about to get, Google or ask me what's difference of squares. Okay. Different squares means the square root of x squared is x. Square root of 9 is 3. Right? And then in order for you to get negative 9, one of these would have to be positive, one of these would have to be negative, right? Negative times positive is negative. So one needs to be positive, one needs to be negative. Doesn't matter which one. There you go. So that one's done. Let's look at this one. So first of all, it's not a difference because plus isn't difference. Difference is minus, right? But also 6 isn't, you can't take a square root of 6. It's not a nice clean number, right? Maybe we could factor it some other somehows. So let's do an x puzzle really quick. 0 on bottom, 6 on top. What numbers, right, because there's no b on bottom, there's no b, 0 on bottom, 6 on top. What numbers multiply to 6 and add to 0? None, right? No clean numbers, which means that it's probably a really gross irrational number, which means we're just not gonna do that. We're just gonna stop there. So we're just gonna leave that one, x squared plus 6, and then we're done. That's it. That's our answer. That's as far as we need to take it. Okay, so this, first of all, before I go any further, this video isn't supposed to be like a fully encompassing, like, I understand everything now. It's just an overview. So again, if you are confused with any of this, you want more information, I've recorded this video multiple times now. I keep screwing it up. I don't want to do this forever. I need to move on. If you're confused about anything, look up Factoring Quartics. you'll see problems that are similar to these. If that green stuff down there confused you, look up difference of squares. Difference of squares. And then that should help you out. Let's move on. So this one here, it's the power isn't as high, but there's more terms, right? This one, we're going to use a method called grouping. Factoring by grouping. So what that means is we're going to take this big old chunky polynomial, split into two groups, left group, right group, split in half, right down the middle, okay? Let's just look at the left half now. So on the left half, we've got 3x cubed plus x squared. We want to pull out a GCF. So what's the most junk that we could pull off of both of those terms without leaving behind any fractions or decimals or whatever? So like, for example, one has a 3, but the other one doesn't have a number, a coefficient, right? So we can't pull out any numbers, but they both got x's. So we could pull an x out of both of them. Excuse me. We could pull two x's out of both. We could pull x squared out of both of them, all right? So if we were to pull an x squared out of them, what would be the leftovers? If we pulled an x squared out of both of those, what would be left over? Well, what happens if we divide an x squared out of both of these? That's what's going to go down inside of there. So on this one right here, the 3 isn't going anywhere, right? We're not pulling a 3 out, we're just pulling the x squared out. So 3 isn't going anywhere, it's staying there. X cubed divided by x squared. 2 of those 3 x's are going to cancel out, just one going to be left over, right? Just one old regular x left over. Okay. Plus, what's x squared divided by x squared? What's anything divided by itself? 1. All right, cool. Put a pin in it. We'll come back to it later. Just hold off there. Okay. Let's look at the right side now. Same thing. We're going to pull out some GCF junk. They're both negative. That's something they got in common, so we're going to pull that out. They're both divisible by 9, right? A lot of people look at this and be like, they're both divisible by 3. Yeah, that's true, but they're also GCF, greatest common factor, they're divisible by 9, right? 9's greater than 3. Can't pull an x off both of them because that 9 done got no 3, right? All right, so that's everything we could pull out. So what would be left over? Or in other words, if we divided -9 from both of these, what would be left over? Well, negative divided by negative is positive. Negatives cancel out, right? 27 divided by 9 is 3. And that x didn't go nowhere. So there. Okay. -9 divided by -9. What's anything divided by itself? 1. Positive 1. And whoa, hey, isn't that interesting? Isn't that interesting? What a coincidence. That's not a coincidence. That should happen every single time. If that doesn't happen, you screwed something up. Or the problem doesn't work with grouping. They both got 3x plus, the leftovers for both of them with 3x plus 1, right? Cool. So what we're going to basically do now is kind of just do GCF again. The thing that both of them have in common is 3x plus 1. So let's put that up front. 3x plus 1. Okay. What would be left behind if we were to pull the 3x plus 1 off both of them? Well, an x squared and a -9 would be left behind. So x squared minus 9. There we go. But, ooh, wait a minute. That one's got a power 2 on it, so we're not quite done yet. But, hey, that's a difference of squares. Remember we talked about that earlier, all right? A difference of squares. X squared minus 9 is a square, right? So we can chop this down just a little further. The one on the left, 3x plus 1, that one's done. There's no powers. It's done. I don't have to do anything, for sure. There's no power on it, so it's done. Difference of squares, x squared minus 9 is x plus 3, x minus 3. There we go. Now we're done. All right, that's it. Again, if any of this was confusing, this isn't supposed to be you've now learned and mastered everything. That's not how this works. It's just a quick overview. Factoring Quartics, difference of squares, factoring by grouping. Those are the things we went over. If you're confused about any of it, look it up, ask me a question. I don't know, whatever. That's it. Goodbye.